we are going to be looking at glomerular filtration rate. Glomerular filtration rate, also known as GFR, is the volume of fluid filled from the volume of fluid that is filled from the renal glomerular capillaries into the Bowman's capsule. So when we look at the structure of the kidney, you see that it has different compartments. We have where we call the glomerular capillaries, we have the Bowman capsule. So GFR is the volume of fluid filled from the renal glomerular capillaries into the Bowman's capsule per unit time. Now, central to the physiologic maintenance of GFR is the differential basal tone of the afferent and efferent arterioles. In other words, the filtration rate now is dependent on the difference between the higher blood pressure created by vasoconstriction of the afferent arterioles versus the lower blood pressure that is also created by lesser vasoconstriction of the efferent arterioles. Now, GFR is equal to the renal clearance rate when any solute is freely filtered. The GFR is equal to the renal clearance rate when any solute is freely filtered, and is neither reabsorbed nor secreted by the kidney. When a substance, for example, is being given, and this substance is neither reabsorbed, it's not something that the kidney will take back and say want to reuse. It's neither reabsorbed nor secreted. Of course, no one something is secreting something, even if you gave the person an exogenous substance, because the kidney secretes that thing, definitely the amount can increase. But this one, I was saying, for example, somebody is being given 50 grams of maybe glucose, and at the end of the day, what is expected is 50 grams, as the output is expected to be 50 grams of glucose. Or even if it's not to 50, probably 40 or maybe 45. But when you are giving somebody 50 grams of glucose and the body is also secreting its own glucose, you expect that the result will never be correct. So GFR is equal to the renal clearance rate when any solute is freely filtered and is neither reabsorbed nor secreted by the kidney. Okay, let's go ahead now. The rate therefore measured is the quantity of the substance. The rate measured now shows the quantity of the substance in the urine that originated from a calculable volume of blood. A particular volume of blood calculated, you see the rate of substance that is being cleared by the kidney. So that shows the GFR. Now, relating this principle to the below equation, there's an equation I'm going to give us. Below equation for the substance used, the product of urine concentration and urine flow equals the mass substance excreted during the time that the urine has been collected. Just follow me. This mass equals the mass filtered at the glomerulus, as nothing is added or removed at the nephron. You know, the nephron is the one that plays most of the filtering function of the kidney. So this mass equals the mass filtered at the glomerulus as nothing is added or removed at the nephron. Now, dividing this mass by the plasma concentration. Follow me. Dividing this mass by the plasma concentration gives the volume of the plasma which the mass must have originally come from, and thus the volume of plasma fluid that has entered the Bowman's capsule. The GFR is typically recorded in units of volume per time. Which is in mils per minute. So I'm going to give us the formula. The formula for GFR, glomerular filtration rate, is equal to urine concentration times urine flow all over plasma concentration, which is equal to renal clearance. I go again. GFR, glomerular filtration rate, is equal to urine concentration times urine flow all over plasma concentration, which is also equal to renal clearance. So there are several different techniques that are used to calculate or estimate the GFR The one we have given above only applies for GFR calculation when it is equal to the clearance rate. The formula I gave us above, which I said GFR is equal to urine concentration times urine flow all over plasma concentration is equal to renal clearance. This formula is only used, it only applies for GFR calculation when it is equal to the clearance rate. So I've said generally, glomerular filtration is talking about the filtration capacity of the kidney, and you cannot talk about the filtration capacity of the kidney without mentioning the Bowman's capsule and the nephron when you look at the structure of the kidney. And at the end of the day, when the substance is being given, it's expected that that substance should be the type that the kidney can neither reabsorb nor secrete, so that it will be able to give us an accurate result. So in our next class, we'll be looking at some substances that we use for clearance. Inulin is one of it. See you in my next class.